recorded at the Southwest Conference on Botanical Medicine in April of 2019. For more information on our conferences, lecture notes, and recordings, visit our website, botanicalmedicine.org.
Okay, welcome everybody. Thanks for being here. 2019 Southwest Botanical Medicine Conference. It's always a treat to come down here to Arizona, especially in the springtime when it's beautiful and sunny and the flowers are popping up. I heard that the botanical gardens are extraordinary this year. Haven't been out there yet, but I want to get there. And I think one of the things that makes this university pretty special for me is that there's a real focus here on plant medicine, on herbs. And I find that I work with a lot of naturopaths in collaborative contexts, and oftentimes the botanical medicine piece is kind of one of the weaker parts of the education for my liking. I think that as naturopaths, the focal point is botanical medicine, and it's moving away from single molecule, single target pharmacy, and it's moving into holistic medicine that's pleiotropic, works with the body, many targets, complex combinations of molecules that together make a synergistic effect of healing on the body. So it's an honor to be here. I'll just say thanks to Lenny and Larry for putting on this conference every year. It's really, really special, and I'm really glad I get to be here. Okay, so neurocognitive decline. This is a big topic. There's a lot of places to drop anchor. There's a lot of, I'm sure everybody here is familiar with and is following the research and following the news. The number one risk factor we're talking about here for neurocognitive decline, anybody guess? I think I heard it. Age. Yes. That's the number one risk factor. That's in any study, you'll find that synonymous. So I just want to preface this talk with there's a lot here, and I want to also encourage you to feel free to ask a question here or there if something comes up, and help me keep this at the level where everybody can follow, because some people are going to want to go really deep, and some people are going to probably have to come up for air at some points because we'll drop in. Anybody have a question to start off with? Anything that's pressing right now? Good. No hands? Okay, well, welcome. Here we go. So we're going to start with aging, because the idea that the concept I just gave you is that aging is the biggest risk factor for cardiovascular disease, or that's tomorrow, for neurocognitive decline. So there's lots of theories of aging, the study of aging, gerontology, the idea that there's wear and tear on the body, accumulation of traumas, scarring, sprains, injuries, anything at all can be part of this wear and tear idea. Then there's the theory of free radical damage, the idea that over time we are unable to handle the free radicals that we face, that we either generate inside the body through our endogenous process, or that we face through free radicals that are entering our body from the external. It can be everything from radiation to toxic chemicals to just normal parts of life, pieces of food and things that we have to break down and metabolize, and then we generate free radicals. That's one part of it. Then enzyme depletion. Enzymes are what? They're proteins that do what? They're proteins that transform molecules. They transform substances on our bodies from one thing to another. That's what we do. That's how we live. So when enzymes get depleted, we're not able to generate all the molecules that we need, all the compounds that are here to support our life. And another theory, accumulated genetic error, the idea that, our genes get altered through the damage that we face, through the challenges that we face, and then the genes become mutated, and as they mutate and get damaged, we see error showing up in our manifestation of those genes in our physiology, because you have the genes themselves, which then are expressed outwardly in who we are, in our physical bodies, right? And that's where people are always like, oh, it's all about genetics. I'm like, well, it is, but you are genetics. You are the genetics here that I can see. This is your genetics expressing itself to me. So we don't have to separate the idea that genetics is where the truth is, and then this stuff here is just sort of woo-woo, whatever. We're just looking at people. No, it's the same. We're going to talk about how that overlays. It's one of the most important things for me in medicine is being able to take that microscopic, rational, scientific view where we break it down to its individual parts and then overlay that on the gross macroscopic perspective of the person in their environment, in their ecosystem, in their family, their emotions, and their physiology. Put those two things together. So the model that I'm going to talk most about today kind of combines these together as the metabolic model of aging and stress maladaptation. So any of these things we could look at that I just described, they deal with stress and the concept of stress, that the body is always facing stress. Gravity is a stress. You know, radiation from the stars in the solar system, that's a stress. Free radicals we talked about. These are all stresses that we're going to face every day. And then there's, of course, emotional and psychological stress, the real stress that we generate inside, how we deal with situations that we face. You know, I just flew in here from Oregon the other day, from yesterday, and I was supposed to get in at 6:50, but of course San Francisco airport was, you know, cloudy and foggy, so a flight got delayed again, missed another flight. They said, oh, you can't get there today. You're going to have to come tomorrow. And I was like, well, I can't come tomorrow. And I could have gotten really stressed out, but considering, you know, what I'm going to talk about today, I think that not getting stressed out is a better plan. So it all worked out. We ended up getting here. I just kept pushing forward, not getting upset about it. And I'm not saying I'm perfect at this stress thing, but the more we can reduce our psychic mental stress, the more we'll affect the stress response in our bodies. And it's that maladaptive stress that leads to early aging, early cognitive decline. So we need to improve our ability to adapt to stress, not just on the physiological level, thinking about it, you know, we need adaptogens, we need to, you know, take in substances that are going to help our bodies, but actually the way that we think about life, the way that we emotionally approach life, that's stress right there. And that's a place we can make huge impact and inroads to preventing these issues. So some of the big places that we're working with today, genetics, chemistry, physiology, and behavior and mood. And this is all part of aging and then neurocognitive decline. So let's talk about the free radical theory of aging just for a minute. Free radical pathology is uncommon in youth and is universal in the elderly. Why is that? It's interesting, right? Science doesn't really answer that very well, but traditional medicine does answer that really well. It looks at it as a condition that's associated with the depletion of our essence. And I'm going to hit that subject here in just a couple slides. The ability for us to manifest the energy to remake ourselves, the energy to cope with the stresses we face, to make the compounds that neutralize the free radicals, we start to lose that capacity as we are depleted slowly over the aging process. So is it a cause or an effect? Are free radicals a cause or an effect? Well, I mean, you know, this gets into this idea that, well, we'll talk about it, kind of aging as a philosophical concept, but free radicals are generated just, like I said, as a part of life. There's no way to avoid it. So they're both a cause and an effect of aging. And then the idea of anabolism, and I'm going to talk about this specifically because it's very important to understand the difference between anabolic and catabolic, is that when we're in an anabolic state and we can rebuild ourselves, we can make those enzymes that we're talking about being depleted, we can make the hormones that regenerate us, then we're not going to age very fast. But if we can't do that, if we are in a catabolic state where we are not able to adapt to stresses, we're not able to quench free radicals, the inflammation and oxidative damage is building. That catabolic state will represent rapid aging. We will age more quickly. That is what catabolic is, and I'll talk about that more specifically. We build antioxidant enzymes to quench free radicals, and I like to talk about the idea of quenching because it's just like if you had a fire and you want to put out the fire, you want to put some flame retardant on there, you want to put some water on the fire, you got to quench it. Well, inside of our bodies, there's little fires going on every moment of every day, all the time. Every single cell in our body has a little nuclear reactor in it, a little generator, a little star that's burning. And we have to both use that star, capture that energy from that burning. We also have to insulate that star and make sure that it doesn't burn the tissues around it and get too hot. And that process is essential to this concept of aging. And the concept of neurocognitive decline, we'll see, is tied intimately to this. So the mitochondria, we all know from science classes that, you know, this is a very important part of our bodies. The kind of prevailing scientific idea is that it was originally its own organism that encountered a eukaryotic cell and found a symbiotic relationship, and eventually they evolved to share resources together, and to the point where the mitochondria got protection and got food and got taken care of and got to live inside of the cell that was part of a bigger organism, and it developed into this really beautiful, synergistic, elegant relationship between mitochondria that make energy and cells that can use the energy to do all the things that make organisms. How cool. And so the mitochondria is a central point now of where we see this breakdown of maladaptive stress. When the mitochondria breaks down, when it starts to malfunction, and we're going to look at what that looks like, we see energy manufacture problems. And whether it's the breakdown in the insulation and the fire that burns the tissues around it, the free radical damage, or if it's the lack of energy production, the energy is not being produced well. The membranes that are in the mitochondria that conduct energy, that transport fats, that make energy, they can start to fall apart. You lose transmembrane fluidity. Issues along electromagnetic problems start to happen. And then we can't produce energy effectively. That's part of this mitochondrial breakdown, a huge part of this central focus in aging and neurocognitive decline. So I want to jump right into advanced glycosylation end products, right? AGEs. They're ages. That's what they are. They're aging. I associate them very clearly with, aging spots that you see on people, on your face or on your hands, places that have been damaged by the sun that your body couldn't adjust to the damage. It could no longer produce enough quenching energy to put out those little fires, and you have damage there. Damage that just shows up as a scar or shows up as a place that's darkened. That's part of this glycation process. And glycation, of course, involves glucose, right? So this is where glucose is reacting with proteins. These are sugar-damaged proteins. It's like rust. And this is where we see how important it is to curb our intake of processed foods and simple sugars. Why? Because they rust our bodies. They rust our mitochondria. They literally cause glycation. We start to break down. The proteins, the enzymes, the structures are damaged. They don't work well anymore. So how can we inhibit this cognitive decline? Stop eating sugar. We don't even need it. Little bits are all we need. So that's a big theme. I just want to tie it back together to glycation and damaged proteins. And of course, when you're young and you're eating sugar and you got tons of, essence, your body's got plenty of energy to keep rebuilding itself and to make these enzymes and to quench those free radicals. It's not a big deal. But as we get older, we see the effects start to amplify and multiply. So let's talk about AGEs. Found higher amounts in biopsied brains of patients who died from Alzheimer's disease than patients who died from other causes. They form in the brains of Alzheimer's disease patients early in the disease process. Elevated levels of insulin or glucose cause formation of advanced glycosylation end products. And then glycated proteins produce 50-fold more free radicals than non-glycated proteins. Again, these are just little generators of damage, of fire. Break down structure, break down proteins, and then they activate free radicals that then activate these drivers of the inflammatory system. Tumor necrosis factor alpha, this stuff right here, which then drives the immune system. And the more TNF alpha that's floating around, the more immunological activity is, more inflammation, and then there's all this cost that we have to pay. There's secondary damage. When the immune system gets fired up and starts doing things, there's a cost. We pay that cost. We get damage. You see this all the time. It's how autoimmunity gets started. And TNF alpha is one of the drivers of autoimmune disease. This is it. That's why we target that with drugs. The TNF alpha inhibitors, Enbrel, Humira, we'll talk about them on Sunday. So I want to just jump out of the science now. If you get kind of like, there's a little overview, a little concept from the micro-rational perspective. Let's pull back for a second. Let's look at traditional Chinese medicine. I'm a doctor of Chinese medicine. That's where I kind of hail from. I consider myself like a Taoist doctor. And my approach is very macroscopic and holistic. And there's the thing about traditional Chinese medicine is its principles of understanding and its principles of treatment are very well defined. They're accepted. They're generally understood as Chinese medicine facts, principles. We all have essence. We all have blood. And blood isn't just what we think of it as blood. This is an essential substance that's defined as, this material that carries our spirit in it, the material that carries the nutritive, digestive, assimilated products from our food into our bodies. It basically fills all of our tissues with the life that we need to keep on going. The bone marrow. Bone marrow is an extension of the essence. Blood is an extension of the essence. So the main concept for me right here, this principle of essence, is essential. And the reason is because it gives you this framework. The idea is that at the conception moment of any organism, there's an exchange between the male and the female parts to create life. And in that exchange, there is generated what's called congenital essence. A certain amount of this undefinable, intangible material that then is the motivating force for that two-celled connection to become multiple cells, multiple, into organisms and structures. And how much essence do you have as an individual is tied back to the genetics, we would call it, but they would say in Chinese medicine, this is your essence, your congenital essence passed on by your ancestors to you, and the connection you made with your partner to make that being. That process defines the essence you have. And of course, as you're developing, there are things that could inhibit your essence, and there's things that could support it. And throughout your life, you're going to expend your essence to remake yourself in every moment. You're going to expend essence in huge amounts when you have high demands. Remember the story of the mom that ran out to save her child from the car that fell on, the car fell on the child, and the mom runs out there and she suddenly lifts the car up. You're like, how is a person lifting a car? In that moment, she had a huge surge of epinephrine and norepinephrine, a huge surge of anabolic activity, and she damaged herself to save her child. In that moment, she used a huge amount of her essence. She aged in that moment. You ever see if someone gets a white streak in their hair? Suddenly there was a very traumatic moment, and boom, they just got a white streak in their hair. That's another example of how the essence got used very quickly. Another great example, talk about marrow, right? One of the places that marrow manifests is throughout, in essence, throughout all the nervous tissue in the body. The brain, the spinal cord, it manifests through the nerves of our whole bodies. The neuroendocrine system. And it manifests in the teeth and in the bones, the foundational structures of who we are. So look at people who are addicted to methamphetamines, and you see people come in your clinic, right? And you see them. They look beat up, depleted. And you know what happens first to them? What do they lose? They lose their teeth. Every moment they go on that methamphetamine, they speed up their body. That's not free energy. It tells your body to use more essence now. Use more essence. And it feels good to use more essence. You're like, yeah, I'm feeling like I'm using a lot of essence. This is so cool. Yeah, you're just dying faster. So, this principle to me is essential to my understanding of how this breakdown of the neurocognitive system, the neuroendocrine system, functions. And I highly recommend that everybody get versed in this concept and share it with people. Because it's a lot easier for someone to understand what I just said to you than it is to understand that there are these little tiny molecules that interact with these little tiny receptors, and there's these little molecules that break up those receptors, and then you're like, what is going on? What are you talking about? Has anybody ever seen a molecule? Have you guys seen a molecule? No, nobody's ever seen a molecule. We don't even know what it looks like. We have a theory about what it looks like. Have you seen a receptor? No. We don't even know. We have never seen them. We're just making up stories. They're good stories. They're helpful, but to me, they're secondary to these principal stories that have defined long-term experiential application in medicine. The concept of essence. Okay. I'm not passionate about that at all, by the way. So some of the things that are really important. Digestion, absorption, assimilation, essence replenishment. I want to mention this because throughout your life, as you make choices, you can make choices that are going to speed up the amount of essence you use, and you make choices that are going to slow down. You can also make good dietary choices that are going to help to replenish your essence, because the idea is that if you eat really well and your digestion's working perfectly, you've got your hydrochloric acid is at a great level, you're breaking down the big molecules into smaller ones, and then it's going down into your duodenum, and all those little fine enzymes are starting to work. The pancreas is releasing enzymes, and they're refining those smaller molecules into smaller pieces. Chinese medicine called this nutritive qi. It was so small they couldn't see it, so they called it qi. And so they absorbed it into their duodenum, into their bloodstream, and then used that to supply all the needs of the body to remake itself. Most of it. But you still had to use a little bit of essence. You understand what I'm saying? You can replenish what you have to use every day by making good choices. Dr. Zeev, good to see you. Hey, brother. I love that guy. So, if we make poor choices about diet, if we have disrupted digestion and we don't assimilate those small pieces of molecular information that feed our bodies and help us build ourselves, then we've got to get it from somewhere, so we use it from our source. And we age more quickly. So adrenal fatigue, hypochlorhydria, spleen dampness, just cloudy digestion, more sugar, more sweet, more richness generates more turbidity in the digestion, ineffective digestion, low hydrochloric acid levels, inefficient enzyme production, a reduction in your ability to make that nutritive chi to support your essence, and overall just a decline in our neurocognitive function. What are the symptoms? We talked about it. Thin hair, tooth problems, dizziness, memory loss, neurological decline, low back pain, osteoporosis and osteopenia, and atrophy of the lower limbs, weakness of the low back, the knees, the lower limbs in general. And that's because the essence is stored in Chinese medicine in the kidneys. The kidneys themselves are the source. And the kidneys rule the low back and the lower part of the body. So, you know, one of those signs I saw somewhere, I think it was like Mercola or something, presented this idea that if you want to understand how you're doing biologically within aging, just how do you get up off the floor? If you're 82 years old, can you just get up quick and easy? That shows a huge amount of your anabolic capacity, your capacity to live and thrive, is that ability to get up off the floor. And I was like, that's so cool, because the low back and the knees, that's where that's going to come from, all that strength, from the kidney essence. So why do we age? Why is there no cure for aging? Will there be a cure for aging? Are we going to bump up against the edges of reality? To bump up against the edges of what's possible? Are we doing that with CRISPR? What are we going to do? Are we going to fix the aging problem? I don't know, guys. I think aging's pretty cool. I think it's pretty amazing that we could have a life where we start out as a little baby, totally dependent on our mother, our family, move into a place of adolescence and power, and then into strength as a full-grown human being, be alive and present and a commander of life, and then dwindle down into a person who has seen a lot but then becomes older and needs help again. That we get an arc of life experience. It's rich. And if we could get past the idea that we got deceived, that we got cheated out of our immortality, we could move into a place of grace, graceful aging, acceptance. Of course, I'm only 47, so, you know, people out there going, yeah, nice try, young guy. Sure, it sounds really great for you. But I'm hoping I can maintain some grace throughout. And I do think there's a spiritual experience happening with aging, and I think it's really an important part of what makes us human and what makes us compassionate and what holds us together. You know, they always say that people come together under extreme circumstances when things are bad. Well, you know, we're all facing death, right? We're all here together. The ultimate consequence is that the individual self is going to disappear, so we should all just decide that that's a severe consequence. Let's all get together, right? Unfortunately, it's not that simple for some reason. So, key aging factors. Let's kind of pull this all together. So, declining anabolic hormones, right? And hormone dysfunction. This occurs as we age. Our quenching network. We don't have enough of that essence to quench the free radicals, to calm down the inflammation. Reduced capacity to neutralize free radicals. More waste byproducts. Those fires that are burning in our cells are generating more byproducts that we can't control. We can't control the inflammation that we use to save ourselves. Inflammation is there to keep us alive, right? I'm going to talk about this on Sunday, because without inflammation, we wouldn't be able to live. It's impossible. But if it gets out of control, it kills us. And as we age, it gets harder and harder to control inflammation. Inflammation starts to become something that we spend a lot of our energy trying to calm down. Immune function decline. Our immune system is driven by inflammation. When the inflammation gets out of control, immune function starts to become unruly. Reduced digestion. We can't do that process of burning up those bigger pieces, making them into small enough pieces to absorb them and assimilate them. Enzymes we talked about, and then more fatigue and a tough time recovering. And I think recovery is a really important concept. And as we look at anabolic and catabolic balance, it's that idea that recovery, when let's say you go to the gym and you work out, how long does it take your body to get back together and feel good again? You know, you start to feel, as people say, oh, I'm getting old, man. It's like I go to the gym and I feel sore for days. I don't get back. That's a sign that we don't have enough anabolic support. We don't have those hormones to signal the cells to rebuild, to regenerate, to renew themselves. That's what those hormones do. So as we talk about diminished or less efficient use of anabolic hormones, we're talking about that inability of the body to signal itself And if you go back to that idea of essence, let's imagine this, take this little journey I'm presenting you guys with, that we're in the kidneys and we're essence, and we want to, help the body rebuild itself. How do we do that? Well, we start out with a precursor. Let's say that we start to become pregnenolone, and we become DHEA. We're going to talk about these. These are precursor hormones. And then we're going to go from that to become testosterone, and estrogen, progesterone, androstenediol. Any of these androgens and supportive hormones that are going to tell the cells, hey, I'm the phosphorylating match. This is the fire that you need to spark that cell, to take the DNA, separate it, make a new cell. Now there's more you. That's what those hormones do. They tell you to remake yourself. If you don't have those hormones, you don't remake yourself. This is a big problem with drugs like Lupron, with drugs that, therapeutic approaches that basically decide that we're going to wipe out your hormones because hormones are the cause of your disease. Well, you can't live without hormones. Watch how bad people feel without hormones, and watch what happens to them. Also, as we age, hormones are less efficient. We get resistant. I mean, insulin resistance is the perfect example, right? The more glucose is present, the more glucose and insulin starts interacting with each other, we start to become resistant to the insulin and glucose relationship. We're not able to get insulin and glucose into the cells. It starts to break down. But it also happens with all of our hormones. Misdirection, feedback loop inhibition. Remember, all these hormones are working on feedbacks. You want to get more testosterone, what happens? The hypothalamus goes, well, how much testosterone's out there? The feels out there? Oh, there's plenty. Tells the pituitary, hey, stop releasing luteinizing hormone. Don't tell the testes to do anything. The testes are like, cool, I'm not doing anything. But then after a while, the testosterone levels start to decline. And the hypothalamus says, hey, pituitary, you need to get some, luteinizing hormone out there. So let's start making some more hormones. So then the testes respond and start making more testosterone. If there's an overall issue, if hormones are out of balance, if hormones are deficient, and then there's no more essence to answer the call, you're in a feedback loop that doesn't work. The body's asking for more, and the body says, I don't have any more. The hypothalamus is saying, pituitary, tell the testes, make me more testosterone. Testes are saying, we can't make any more. We're giving you all we've got. And that's when we reach this point of like, man, we're breaking down. And what's so cool, you guys, is that with botanical medicine and key nutrient medicine, we can supply what the body needs to keep making that stuff. And that's really why I love this medicine so much. So what happens with aging with hormones? All these things are tied to hormones. We talked about the essence part, but hair loss, fat distribution, and hair loss again. This is some people's hair goes away and some people doesn't, right? So you can't just make a straight, as we get older we're all going to lose our hair. That's not how it goes. But definitely as the hormone dysfunction occurs and enzyme activity changes, testosterone starts to become dihydrotestosterone, which leads to what? It leads to male pattern baldness. It leads to hair growing on your back. It leads to acne on your face. It leads to polycystic ovarian syndrome. That's one of the hormone-related enzyme deficiency issues or enzyme upregulation issues that causes these dysregulations in our physiology. Muscle weakness, fatigue, recovery, urinary incontinence, that the kidneys hold the gate of the urine to hold it in. Loss of cognitive function, depression, sexual dysfunction. I tell you guys, it's one of those personal questions you have to ask your patients, right? So, how's your libido? I ask just about every patient that question, even though it's a tough question to ask, because to me, it's such an essential part. Two things. What's your appetite? Are you hungry? Do you want life? Do you want to eat life? Do you want to get life? And then, what's your libido? Do you have a passion for that? These are strong indicators of how people's reserve of hormones is, what their life force is like. It's worth asking the question and dealing with the personal sort of, hey, I don't really want to talk about my sex life. It's okay to go there because it's important. It really is important. And if you can tell people, hey, this information helps me see how I can help you. So here's this catabolic anabolic. I just wanted you guys to see this. The building up of ATP is an anabolic process. We make adenosine triphosphate as a substrate to hold structures that can be broken then by catabolic process into energy, right? So over here we see energy sources. Big molecules get broken down into utilizable energy or heat. We always kind of get a little bit of loss, right, when we're burning things. And then metabolic products. And then over here on the anabolic side, you're building things. You're building these enzymes. You're building intermediates, biopolymers, long structures that then are used by our body as structural components to make us ourselves. That's anabolic. So anabolic, catabolic is super important. A lot of plants that we have, a lot of the adaptogens, a lot of anabolic adaptogens are really good at pushing away from the catabolic side. They're anti-catabolic, and they push over into the anabolic side. They help your body rebuild structures. That's key, because as we age, we're breaking down. It's catabolic over anabolic. What are the key anabolic hormones? Estrogen, testosterone, progesterone, DHEA, human growth hormone, right? Insulin like growth factor 1. Insulin. Insulin is an anabolic hormone. Very important. It brings glucose into the cell and induces all kinds of cellular activity. Insulin gets a really bad rap, and it is just as dangerous to be in high levels as glucose is, but insulin is really essential. We need it. It's really important. It's a strange approach to treat diabetes by giving people huge amounts of insulin. We should be finding every way we can to not have to give people tons of insulin, because insulin is very damaging in high levels. You know what happened when people started taking human growth hormone, right? It was a big thing, like a fad, People started getting cancer. They quit that really quickly because there were a number of studies that showed, whoa, you start giving people human growth hormone and it doesn't just grow good stuff. And that's what happens with a lot of supplementation of these hormones, is that we get into trouble because they're all malleable. They can all kind of become anything else. They're not just a stable structure. I always talk about the Pachinko game, that Chinese game where you put the ball at the top and it goes ding, 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 comes out at the bottom in one of these different slots. I don't know if you've ever seen one of those. But that's what I think of when I think about hormone metabolism. You put things at the top and they sort of run down through any kind of metabolic channels that your body is running, and you end up with a metabolic byproduct. We don't know what that is. So it's risky to give people hormones without understanding how they metabolize them. So just a quote, generally better quality of life, higher testosterone, higher free testosterone, higher DHEAS, dehydroepiandrosterone. This is, again, a precursor hormone that we're going to talk about because it's really important. And then lower hemoglobin A1C. Are you guys familiar with that? Yeah, right, a marker of glycation, right? This is hemoglobin in our bodies that's been damaged by sugar. Sugar oxidative damage. And that's tied to your fasting insulin, your fasting glucose, your C-peptide levels, the levels of sugar and insulin in your bodies, and how your body is adapting or not. This is the damage that's occurring, hemoglobin A1C. So one of the things about anabolism is that as we age and we start to lose that body, the ability to rebuild ourselves, we see a condition called sarcopenia, right? Not the same thing as cachexia. Cachexia is what we see when people take, where they have pancreatic cancer, they take high doses of chemotherapy, and then their body quickly breaks down under the influence of a severe insult. Sarcopenia is the more gradual loss that occurs. It's muscle loss. Loss of muscle over time. That's generally due to a lack of these anabolic hormones that tell our body to rebuild itself. So that's just a really good indication of aging. So body mass index and exercise. Exercise, and I'm going to talk about this because it's so important to exercise, because if you don't do stuff, if you don't ask the body to respond, it won't. But if you tell the body, I need more because I'm pushing myself to do more, the body will respond by making more testosterone. Right there, just exercise. And certain kinds of exercise we'll talk about. So as we talk about stress now, I want to dig into something called hormesis, and this is a really cool concept. It's not related to hormones. What it is, it's the idea that small amounts of something that would be a toxic insult, something that would be damaging or harmful to our bodies, requires the body to respond to it by building the solution. You guys follow me? A small insult, the body says, hey, I need to figure out how to deal with that stuff. So the body builds a system. And the body already has lots of systems. We do a great job. We've got beautiful systems for dealing with radiation, because we always have a little bit of galactic radiation that's coming at us all the time. The Earth is a radiant body. We're always adapting to radiation. So we have a system to do that already. We have systems to cleanse free radicals. We make them. We need to cleanse them. We need to clear them. So we're really good at it. So if we suddenly take away all the toxins from our body, we just put ourselves in a bubble, our body will stop building the systems that it uses to get rid of the insults. But if we expose ourselves to small amounts of toxins over time, our body gets better and better at adapting to them. Does that make sense? Here's the kicker, though, is that there's a threshold. If you start getting that toxin over the level at which your body can manage coping with it, where it becomes a damaging insult, now you're out of the hormesis area and you're into the damage area. So where is that balance? And that balance is defined by each person, by their experience, by their body's ability to cope and adapt, how well those systems can, build that response. But hormesis is really important because it's You ever see the people that are like, oh man, I fast all the time. I cleanse. I'm on the next cleanse. I'm doing, clay baths. I'm doing salt baths. I'm just drinking green juice. I'm not getting anything. I don't ever get around any toxicity. They're the sickest people I ever knew. Their face is always breaking out. They're always it's like anything. Like this carpet would be venting too much, glue that they just start reacting to it. So we need a little bit of exposure. And we're going to see that when it comes to things like alcohol, coffee, chocolate, all kinds of things that we love. How do they work, and how do they actually help us when we keep them in the right amount? Don't overdo it. Okay, so stress. All living creatures are in a constant physical and behavioral interchange with their surroundings, the ecosystem, and it's all about responding. So we are stress responders. Adaptive energy, efficient response. Our energy bank, or our energy reserve. What is the cost of prolonged stress? The cost of prolonged stress is that we start to break down. There's a difference between acute stress and chronic stress. There's a difference between acute inflammation and chronic inflammation. It's chronic stress every day, all day, that most people around the world are living in right now, that is driving us to age more quickly, and not just die more quickly, because we have all these, interesting solutions to try to keep people alive. But it's not like they're living with a quality of life. You're having all these breakdowns in cognition and mood and behavior. All these things start to fall apart. I don't know, but who wants to be alive forever if you're just breaking down? That's not the point. We're missing a lot in here. So the cost of prolonged stress is that we start to have a reduced quality of life. And it doesn't take very long. So how does chronic stress impact the brain? I mentioned the hypothalamus, pituitary, adrenal, kind of this as a central network. This is the neuroendocrine network. It's a slide I borrowed from Donnie like 10 years ago, and it keeps coming up because it's great. The hypothalamus sends out releasing hormones. Here you have corticotropic releasing hormone. Sends a message to the pituitary, which releases adrenocorticotropic hormone, which then tells the adrenal glands, hey, I want cortisol. I want some more glucocorticoids. And cortisol is our primary steroid precursor. What's our primary steroid? Cortisone, right? That's why you go to the store and you get hydrocortisone cream, because it's a steroid. It looks just like our cortisone, and what does it do? It puts out fires. That's what steroids do. That's why we use them all the time. That's why medicine, steroids are so popular. You give somebody a steroid and the fires go out. We have all kinds of degrees of them now. We've got cortisone, we've got prednisone, we've got dexamethasone. They're all stronger and stronger versions of steroids to put out fires. Well, this system right here, which is a central organizing network for our bodies, the hypothalamic pituitary adrenal axis, is where we start to see stress affects us in a huge and profound way. We start to lose the ability to effectively adapt and keep this system of feedback loops running smoothly and harmoniously. And the adrenal gland, in my analogy of the essence idea, the adrenal gland is the command center for essence output. How much essence are you going to release at any moment? And if you're under stress and your hypothalamus is telling you we need more glucocorticoids, we need more cortisol, you're going to be depleting your essence quickly as cortisol. You'll start putting a lot of it out. And like I said in that other analogy, from the adrenal medulla, the central part of the gland, we make the other tyrosine-based compounds, right? Epinephrine and norepinephrine, which are then released to increase your heart rate, get you ready for the fight, get you ready to run from the bear. But we start running our bodies in that state all the time. Mental stress, emotional stress. Oh my God, what's happening in politics? The Mueller report. Holy crap. Jesus, I can't sleep. Oh, that's not good. Sleep is so essential. And this system, I want to just make sure that we understand it, because this is kind of one of the backbones for how we're going to deal with chronic stress and preventing the aging response. So we have kind of an off and on system in our bodies, right? Stimulating or arousing, that's kind of one of them. We would turn biochemical systems on, or the turn off, inhibit and dampen. And I put up here, like, when you turn on, when you stimulate or arouse, immune function and digestive function gets less of the energy and attention of the body. More attention goes into being stimulated. What's cocaine? It's a dopamine agonist, right? It pumps up dopamine receptors. It's very stimulating. It's very self-rewarding. People are very excited about it. But in the end, your immune system starts to fall apart. You get sick really quick. Your digestive system doesn't get any attention. You start to break down. You're not getting nutrition. And it, again, ages you very quickly. It makes you put out a lot more essence, this time in the form of dopamine, rather than in the form we talked about before of putting out with methamphetamines. So the other side of it is to turn off, to inhibit or dampen responses, like so you calm down. And I mean, we are a culture that's addicted to stimulation, right? More. How many screens can I have going on? How many phone calls? How many texts? How many events are happening? My God, it's just overwhelming. Stimulation. We are the addiction to stress culture, and the whole world is catching on. And the sad thing is we should be addicted to rest, meditation, and calm, because that's when our digestive system gets all the juice. That's when our bone marrow gets replenished. That's when all of our formed elements are made. That's when our immune system turns on and helps us and keeps us alive. So we have this process, and one of the ideas I put up here is just glutamate and GABA, right? This is sort of a simple neurological binary response, where there's GABA receptors that calm the neurological response, that calm the body down, and there are glutamate receptors that excite the body and excite the system. You know, monosodium glutamate is a great example. It's basically glutamate as an excitatory neurotoxin that was used as a food that made people really want to eat more of that food. So this gets us back to the idea of adaptation, to adjust to various stressors. And the idea of allostasis, and I'm not going to do much with this because Donnie's going to spend a lot of time on it tomorrow, is how we adapt to stress over time. That's allostasis. It's the body's ability to continue adapting over time. So we talk about homeostasis, right? You want to keep yourself in homeostasis, but there is no real homeostasis. It's just, it's a movement. It's a sine wave between, you know, being too much or too little in just about every system, and then just kind of balancing it out, finding that spot in the middle. But that's allostasis. And when allostasis breaks down, when we don't have enough reserve to deal with the stress, then we have dis-ease, right? All kinds of physiological problems start to show up. So talk about the steroids, cortisol and DHEA. I'm gonna talk about DHEA a little bit more because these two are kind of like a yin and yang pair. DHEA is our precursor hormone to making our anabolic hormones that regenerate our bodies. And cortisol is our stress response hormone that basically pushes energy away from rebuilding ourselves and makes sure we're okay to deal with the threat at hand. These are on opposing sides of that on-off thing, cortisol and DHEA. We'll hit this more. So DHEA counteracts the damaging effects of cortisol and glucocorticoids. And of course, these are super important things. We need cortisol, right? We need glucocorticoids. We have to have them. We've got to put out fires. We're constantly spending energy to keep things calmed down. That's where most of our energy goes in life. But DHEA on the other side of it is going to direct our body to rebuild itself. So DHEA actually counters the damaging effects of cortisol. Neuroprotective actions, whereas corticoids, aside from their job to, reduce inflammation, over time, under the chronic influence of high levels of cortisol, you'll see actually neurological degradation. And DHEA can reduce the neurotoxicity of glutamate analogs. And that, like I just said, like monosodium glutamate, things that are excitatory neurotoxins. And I mean that because overexcitation of neurons damages them. One of the ideas here from a paper from 2015, DHEA is considered a neurosteroid, meaning that it's a steroid for the brain, meaning that it puts out the fires in the brain. It calms down that overexcitation. It reduces the free radical damage that's occurring, that's leading to the things we're going to talk about, the neurofibrillary tangles, the Dow protein hyperphosphorylation, the accumulation of amyloid beta, the proteins that start to build up inside of our neurological system that break down its ability to conduct information efficiently. DHEA protects us from that. It goes through the blood-brain barrier. The DHEA sulfate goes through the hypothalamus. Very influential on that central HPA axis I was mentioning, stress response. It's a substrate for estradiol and testosterone. It's where we make those compounds from DHEA. Neurosteroids, what do? They're antioxidant, anti-inflammatory, and have anti-glucocorticoid effects. Neuroprotection, neurogenesis, neuronal survival, apoptosis, the natural cell death cycle. DHEA is so important. So simple, right? Let's just give everybody DHEA. We got the answer, right? Well, here we go. 50 milligrams per day of DHEA conflicting results, inconsistent, randomized clinical trials, longitudinal studies. The current data do not provide clear evidence for the usefulness of DHEA treatment to improve cognitive function in older adults. Why? Pachenko. DHEA doesn't stay DHEA when you just take it orally. It goes through all kinds of metabolism to get to where it's going, to get to the brain. So let's talk about the brain. But let's talk about the brain outside of what's in your skull. Let's talk about the brain as it relates to the center of our, what in Chinese medicine is called the yi, or our intelligence, our intellect, which is actually in the spleen as a functional organ in Chinese medicine, which is, in modern terms, the duodenum, part of the stomach, the pancreas, part of the liver and gallbladder, and part of the spleen itself. The central focus of transforming food into the digestive components, the digested components that we can assimilate into our bodies. That's what the spleen does. And inside that network, we already know there's over 500 million neurons there. It's where our microbe population lives. There's 10 to 1 microbe DNA to human DNA in our bodies, just in case you weren't aware. 10 to 1 microbes. I am a human biont. I'm microorganisms. I look like a person, but I'm really just lots of microorganisms making this thing work for me. And that brain that's here, when you talk about, who feels it knows it, right? You feel it right here. You don't feel it here, you feel it here. And then the message about what that is, and the filter of your brain turns it into what we think about and how we communicate about the world that is. But this brain right here is so important. It's so essential to our neurocognitive success. So what is breaking down our central brain? I call this the first brain. The mesenteric brain. It's the first brain to me. This is the second brain. It's an elaboration of the life experience on the simple fact that we are tubes that have an entry and an exit, that we take in nutrients and we release them, and we build around that complex structures of an organism. Every single living thing does this. The basic life structure, the shape of conscious life. So the things that are really making this hard on us right now are altered food supply, our toxic environment, stress, worrying, overwork, lack of sleep. You can't replace sleep in life. You have to sleep well. And not exercising. You can harp on those things forever. So what do I mean by altered food supply? Modern agribusiness, monocropping, harvest and storage, fertilizers, pests and rodent control, the drugs that we use, these insane amounts of chemicals that we use to control the environment to make us be able to grow huge amounts of foods that have very little value. Refrigeration, transportation, we're moving stuff all over the place. We're not eating locally. We're getting stuff from all over the world. It's been around for a while. It's not fresh anymore. The way we process it, the way we distribute it. And then GMOs, we're not even going to touch that subject because it's just scary. Here's just a list of the toxic environmental things. Just take a look. It's just there for you to think about. It's nice to have these things in your mind when you're thinking about all the things that we're dealing with. Because as you'll hear, anybody who's involved in environmental science, environmental medicine is going to say, it's interesting to look at the fact that, yeah, sure, this one compound we got, a chemical that we had put in people's bodies had some kind of an effect. That's great, but what about when you take 20 compounds and you put them together? What about 800? How does that affect us? Well, who's going to study that? How do you start separating out what's the effect of one compound, what's the effect of all of the interactions of many, many compounds and their cumulated damage? We don't know. So this is from David Perlmutter, awesome doctor who wrote a book on the microbiota. They influence all manner of physiology, from our immune system to our metabolism. I love it that DNA sequences have now been found in the human genome. That's how close our interweave is with the microbes. They're a part of us. They're a part of our DNA. We don't live without them. And if we don't feed them the right food, they don't do the right things for us. You follow me? What is our immune system doing in the gut? It's shepherding and farming. Shepherding little animals, little creatures. And we need them. So the point here being that this central brain, this first brain in our gut, is so influential on how we think, how we see the world, how we feel, what our choices are, what we eat, what we don't eat. So neurogastroenterology is the study of this system, the intrinsic nervous system. It's separate from the autonomic nervous system. They actually did some tests where if they separated the brain in mice, there's so many animal studies, and I'll just preface this whole talk with the fact that a lot of the data we have on herbs and nutrients is in animals because they're not patentable, and nobody's willing to pay the $500 million to $2 billion to get it through phase 3 trials, to have all the randomized clinical trials to approve a plant as a drug. It's just not going to happen. No one's going to pay the money because you can't make the money. Unless we could get our act together and make it education and make it health and, share the burden. But that's a whole other story. But they actually cut off the nervous system, the brain from rats. They kind of connected certain parts and they took away certain parts. And they found that the mesenteric brain, as long as it was intact, all of its functions kept going. It doesn't need to connect with the brain up here. It's functioning on its own. It's independent. And most of the signaling that's going between the brain here and the brain here is going from the gut to the brain. This is where the information center is. And the reason I'm making this such an important part of this whole thing is because if we don't address this part of our brain and our cognition, we're going to miss it. And we're targeting acetylcholine in our brains. We're targeting beta amyloid in our brains. We're targeting neurotransmitters in our brains. We're targeting neurons that... Whoa, slow down. That's all secondary or tertiary to this part of our brains, where the messages are coming from and where the neurotransmitters are being made. 30 known neurotransmitters made in the gut. Now there's I think the newest one is 40. Here's an interesting hypothesis I wanted to bring up. And I'm just going to dive right into how the digestive brain, the mesenteric brain, is essential to how we function in our cognitive brain, the brain in our skull. An intriguing hypothesis from Stilling posts that during evolution, microbe-brain interactions critically influence brain evolution towards the development of the social brain. Basically saying that bugs wanted to share with other bugs, so they would just get us together to eat, and we'd share stuff, and then the bugs would interact with each other, and we'd get diversity. I love that thought. You know why? Because if you look at the blue zones around the world where the people live the longest, we're always looking to find out what were they eating that gave them the life that they have? What was the thing that made them live long? It's not a thing. It's their community. It's the people. It's the meaning in their lives. It's the sharing of experience. It's the sense of place and purpose, that I have something that I'm a part of. Not the isolated individual in their room at home on their freaking Facebook page. So what happens here is the microbes are communing with us. Commensal microbes. Commensa means eating at the same table, right? They're commensal microbes. And then there's symbiotic microbes, ones that just are part of us and really like what we give them, and they give us a lot of good stuff too. And what makes a microbe population work for humans? Well, we looked at all these different possible combinations. It's not any one bug or combination of bugs. It's diversity. How many different ones do we have present in our bodies that can face all kinds of different challenges and can share the load and can adapt to different foods or different shortages, different nutrient deficiencies? Different microbes have different capacities. And as long as they're all playing together nice and having a good time, then we're going to have a good time. So serotonin is the neurotransmitter here that I wanted to mention in that slide about community, about purpose, about place. Serotonin is the stuff that when you take it, when you have a lot of serotonin in your body, you're feeling really good, everything's beautiful. Other people are beautiful. You don't look at other people as, oh man, what's wrong with that person? You look at them and you go, man, you're beautiful. God, life is good. Well-being. I feel great. You guys are all great. You're all beautiful humans. Serotonin. It feels good. I want to get together. Well, let's hang out. Let's share. Let's have food together. Serotonin. Love this stuff. And where is it made? 95% of it's made here. Not here. So dopamine. At this point, we've understood that 50% of it is made in the gut. And we talk about dopamine, right? The self-reward. The great example is someone's looking at their Facebook page. It's like, you put up a post. It's like. Ooh, I feel good. Like. Oh, man, I'm important. I feel good. People like me. Dopamine, Another great example is how dopamine and ghrelin work. Ghrelin is a peptide hormone from the fat cells in the body, and it really starts to influence psychosocial stresses and how we get that self-reward system going. It's like, imagine the person that's having a hard time at work because they have a kind of a petty tyrant as a boss, kind of keeps the boot on head with them all the time, and at work they're kind of suppressed and feeling not good about themselves because someone's always picking on them and telling them they're doing a bad job. They go home, God, go home, open the freezer, ice cream, nice scoop of ice cream, and pretty soon those microbes making dopamine. It's a connection. We're feeling good. I feel good about myself. I'm happy. I just got dopamine. My bugs are happy because the bugs that are there that make the dopamine like the ice cream, so it's all a good thing. But that idea is very interesting because there is this social stress part of it, and dopamine is woven into it through its reward and food, and how social stresses drive us to eating in different ways that are not healthy for us. Dopamine is tied to that. Increased body weight and obesity. High energy, low nutrient foods. Go to the cafe, go to the bakery, go to most shops at the airport, wherever you go, most of it's going to be high energy, low nutrient. That means there's a lot of sugar, not a lot of other stuff. Vegetables are the opposite. 40 known neurotransmitters produced in the gut. The main ones we talk about, dopamine, epinephrine, norepinephrine, serotonin, GABA, acetylcholine, the main target of the drugs, right, that are trying to prevent Alzheimer's disease. Oxytocin, another really feel-good neurotransmitter. Here's just some of the microbes connected directly to what they've been shown to make. They make these neuromessengers for us. Streptococcus. Think, oh, God, strep infection. Strep's bad, right? And I'm just going to make one statement about infection, especially to all the naturopaths here, is that I don't really like the word infection. I hate the word germ. And I hate the word hate, so that's really bad. But infections would mean that there's something that is not in us that then gets in us and makes us sick. Okay, I understand that. I hear that. I would like to use the term imbalanced microflora, microbiota. Streptococcus is not a bad bug. It's just that when it starts to gain a foothold in our ecosystem, it manifests symptoms associated with strep infection, like unhealing wounds and fevers and scarlet fever, right? That's all problematic, but that's not because strep is bad. Maybe you got strep infection because somebody was sick with strep and they had a lot of that bug and they gave you a bunch of it and then it overwhelmed your immune system and then it took hold in your body. That's happening all the time, right? That's communicable disease. You get the flu and then someone else is close to you and then they get a bunch of virus from you and they don't have the capacity to overwhelm that virus and it gets a foothold in them and they become sick. But I mean, if that was the only thing that was happening, then everybody that got exposed to the person with the flu would get the flu. But they don't. Because different people have different immune systems. Their immune systems face different pressures differently. You go to a group of kids at school, one kid gets sick, then 6 other kids do get sick, and 12 other kids don't get sick. What about the guy who goes out in the forest? He's out in the woods, it's cold, he's lost, he sleeps out there, it's really cold, he's shivering all night, wakes up in the morning sneezing and coughing. Oh, and he's got the flu. Where did he get it? Was the flu floating around in the air? And a big glob of it went in his mouth? Is that what happened? Yes? No, what happened? How did he get the flu? How did he get it? Come on, somebody tell me. What? He already had it. Newsflash. Emerging evidence indicates that disruption of the gut microbial community impairs mental health. Antibiotic-induced gut dysbiosis leads to impaired object recognition in mice. Okay, so now we just moved into antibiotics. Are they good for our gut? They're great for emergencies, right? Just like it's an emergency right now to build a wall, right? Forget cyclones and global change and... Antibiotics are really bad for the gut. They're bad for the gut brain, and they're bad for the brain up here. So, and that's been proven. The animal studies, again, we don't need to really go into it. Here's just the idea of depression. I'm going to talk a lot about depression because it's so important. When we don't feel good, we don't make good choices. When we don't feel good, we don't have a lot of activity in our nervous systems. It's like exercising the brain, exercising the mind. Depression, isolation, major factors. So germ-free mice that were actually they were sterile, mice that just didn't have anything at all. They were aseptic. They had antisocial behavior, problems remembering things, and they act recklessly. Okay? Rats given stool from depressed humans, they exhibited signs of depression and anxiety. This is like, fecal microbiota transplant, right? Fecal microbiota transplant's amazing. But you better pick your donor pretty carefully, especially after all we just talked about, right? Better be somebody who you really like, So rats given stools from non-depressed humans had no changes in their behavior. The Walkerton flood is just an area that they discovered that people were getting sick way down the road from the water. I really don't have time to go too deep into it today, but depression in the gut, these people all started getting depressed, and they realized it was from the water contamination that had happened. So I'm just going to jump over to diet as we're talking about the gut. And so, the idea of, take the idea of food and say that it's information. Food is molecular information. It informs our genes about our environment. It modifies gene expression, right? You see how much, epigenetics is influenced by food, right? We know now that single nucleotide polymorphisms, our genes, how they're coded, and the way they turn on and off is affected by what we eat in our lifetime. We can turn them on or off. We could turn them on or off and then pass that information on to our kids. We've seen this now. You could all eat terrible food as kids and terrible food as adults, change a bunch of genes, and then have offspring, and those offspring will be facing some of the challenges that you created. We're doing that. So we're not directly changing the structure of the genes by what we eat, but we're changing how they work and the epigenetic domain. The epigenetics are kind of like, like histone deacetylase, like the way that the genes function in relationship to each other, how pressures around their environment affect what they do, how they manufacture their protein. That's supposed to have a function. Epigenetics, very important. And diet is a key place that we can affect how our genes function. And I'll have a little bit on diet at the end because I think you guys all probably know what diet we should be eating, and most of us know. It's a lot harder to do it than it is to know it. I could speak for that. So the single nucleotide polymorphisms, these are the SNPs, right? This is how we make our proteins. And, when we're looking at things, people say, you're looking at people like, oh, you've got depression. Pretty much, in the last 5 years, what's the main SNP everybody wants to look at if you have depression? Anybody know? Somebody say it? What's the main SNP? I mean, this guy got really popular, especially it became popular in functional medicine, and then it became popular in modern medicine. Sort of like most doctors would say, you're having some depression? Okay, let's test you for MTHFR, methyl tetrahydrofolate reductase, right? This is a major factor, a SNP, that if it's altered, has an impact on how your body metabolizes folic acid, which then has an impact on how your body manufactures dopamine and serotonin. So how you feel. So that's one simple example of how we're looking at these SNPs. What we don't understand very well is how we turn them on and off. How can we alter the SNP in our lifetime? How can we make decisions about how we alter it so that we don't pass it on to our offspring? How do we change it in our offspring so they can change it for their offspring? These are the fun things I think about that we could be doing with all of our resources that we don't do very often. Here's a kind of a concept I saw. I really like this. Genetics loads the gun and environment pulls the trigger. I like that analogy. You guys get that? Okay. I'm sorry for the gun reference, war stuff, but just seemed to work. So I just want to mention the ketogenic diet because it's a really popular diet right now, and its historical usage is in epilepsy and seizure disorders. It's basically a diet that's very low carbohydrate and very high fatty acids and also proteins. It functions by shifting the metabolism in the body away from a very glucose-driven metabolism, glycolysis, which produces a lot of lactic acid, which is kind of our short-term energy system for stress, into more of a fat utilization, fatty acids, right? We beta oxidize fats, meaning you take a fatty acid and you cut it into these pyruvate portions, and the pyruvate goes right into the Krebs cycle and makes ATP, and there's no byproduct. It's really cool. But I'll tell you what happens is that this diet can be really useful in epilepsy, in seizure disorders, but it's not a long-term solution for human health. And you're going to see, both with this and with this kind of like this paleo stuff, like the problems we're going to start seeing, as naturopaths, you're going to see these guys come in your office with all kinds of problems that are related to these sort of cool fad diets that have health-related effects, but really are not the way that humans need to eat for health. So I just wanted to kind of talk about that. I mean, for me, I work with cancer. That's my number one, passion in life, and the thing that I treat the most of all day is cancer. And so glioblastomas are probably the most terrible cancer I see. That and pancreatic cancer, some aggressive renal cells, and maybe acute leukemia. But those, pretty much those are the most devastating diagnoses you can get. And one of the most effective treatments we have for glioblastomas is ketogenic diet. Shift the brain to fats. Just go to fats. And what I do with patients is I don't leave them on that consistently, because cancer is us. It's our cells. It has all of our tools. It adapts like we adapt. And if you just put a ketogenic diet on somebody, especially with most cancers, aside from the brain, the cancers just learn to do that too. So you've got to be pulsatile. You shift. You go ketogenic, intermittent fasting, water fast, vegan, paleo. Keep shifting the diet. Don't put it into one diet and stick with it. Because I've seen that with keto. People are like, I'm doing a ketogenic diet for my breast cancer. Maybe it works for a little while, and then after a little while longer, it's not working anymore.
How often do you shift the diet?
Depends. Happy to talk to you about it, though, in detail. There's some cool cycling you can do. And especially if people are doing other treatments, you integrate those into what you do. Here's just, for you guys, just a little ketogenic diet resource. That's just for you guys to have. So nutrigenomics is the junction between health, diet, and genetics, or genomics, the study of genes, the modification of gene expression through food, preventing and repair cellular damage at the genetic and epigenetic levels. We talked about that. And inducing apoptosis is really an important piece here. And the reason I have that in there is because one of the things that is interesting about this whole idea about dying, right? And I said, what's the cure for aging? Why isn't there a cure for aging? The next question is, why are we afraid of dying? Why are we afraid of dying? Because I can't imagine a world without me in it? Is that what it is? I'm pretty selfish. I'm scared about there not being a me. But if we take the analogy of as within, so without, with disease, what's our number one killer? Cardiovascular disease. Well, that's the heart, right? Are we acting out of our heart? Maybe there's something there for us to think about. Let's talk about uncontrolled growth. What's that? Cancer? Yeah. Well, do we have that anywhere in the world that we can see? Maybe. Maybe there's a connection. What about fear of death? How about cancer cells? One of their most unique characteristics is that they have lost the ability to die. They're afraid to die. The loss of apoptosis. Apoptosis is normal cell death. It's when a cell is doing the wrong thing. It's broken. It's not good anymore. It's time for it to go to the next thing. And the immune system says, hey, you're done. You're out of here, buddy. And then the cell goes, thanks, man. I'm cool. Peace out. See you next time. But in the cancer, it's like, no, I'm good. I'm just going to stay here. The immune system's like, no, you're broken. You should go. And that cell's like, nope, cool. Check it out. Oh, and by the way, there's 2 of me now. How's that? Nope, 4, 8, 16. I'm never dying now. Give me everything. I want everything. That's cancer. And so, I can't help but thinking about cancer and thinking about disease and then thinking about how we act in the world and the as within, so without. That's a whole book and a story. I'm not going to go too much further, but laughter, best thing for the gut. This whole idea, right? The kings and queens, they just knew that if they laughed, they digested well, Question. 5 minutes. You guys want to break in 5? Does that sound good? Yeah? Okay. So laughter is super important. And again, as we laugh, then the signal between the vagus nerve, that whole vagus connection to the mesenteric brain, is this amazing flood of neurotransmitters and well-being compounds, feeling good with laughter. Now, there can be pathological laughter too. It's well defined in Chinese medicine. People that laugh all the time, that's a heart fire. That's like that's out of control. That's not good. we want to be in that balanced place, but we want to find, people who are just like, oh, ha, 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 that's funny. Yeah, you're like, it's not funny, man. That's not funny. But there's a really good place for it. And so laughing while we eat is really important. It helps us digest and absorb our food, and we can't overestimate how important laughter is.